this is the same stuff we just did, except for there was one transformation we didn't do last class, and that was what's called a phase shift. That's what we call it when it's in trigonometry. It's called a phase shift, but it's just the translating left or right portion of it. That's what we did not talk about yet. At the top, you will see these formulas, and I don't really use the A, B, C, or D because we know what A is. It's a vertical stretch or shrink, and like we know where to put that in the table. But some other teachers might teach it with an A, B, C, D. What I want you to notice at the top is that the B value, in order to use the translating left or right that's in the parenthesis there, the B value has to be factored out of the parenthesis. And we did this in chapter 1 too. When there was a number in front of that X, we had to like factor it out before we could find the correct left or right translation. Remember that? We're doing the factoring before. So it comes back again. It's the same thing. Well, maybe the second time around, it's going to be a little bit more familiar. We will remember it. So first example, we've got y equals sine parenthesis 2/3 x minus pi over 6.
Oh, boy.
Is the b in the correct place right now?
No.
No. So we have to factor that out. And what operation is factoring? It is division. Factoring is unmultiplying. So I'm going to unmultiply that 2/3. I'm going to undistribute that 2/3 from the x, and then I have to undistribute the 2/3 from the pi over 6.
That just confuses me.
Well, we have to divide it, right? We have to divide it. So we're going to have to take pi over 6, and we're going to have to divide that by 2/3. How do you divide by a fraction?
I don't know.
You multiply by the reciprocal. So instead of divide by 2/3, we're going to take pi over 6, multiply by 3/2. So you get like 3 pi over 12, you reduce it, pi over 4.
Why do we have to do that?
So that when you do your, what'd you say? Because when we do our translating left to right, do you see how here it would be a pi over 6, but here it would be a pi over 4?
Yeah.
Like, if you don't factor it out, you're going to translate left to right the wrong amount.
So why? Never mind.
Because we always multiply before we add. So in order to do this in the correct order, you have to know this factor. Otherwise, it's not going to work out right. I don't know how. Do it. All right. Now, I'm not requiring you to write the transformations this time. We practiced already writing them. We just have to put them in the table correctly. So up here, we've got a 2/3, and the 2/3 is a horizontal stretch by factor of 3/2. So up down in our table, we'll put multiply by 3/2 for all of my x's. We'll do that real fast. Oh no, we got to multiply by fractions. Remember, multiply by fractions, you can just go straight across. So 3 pi over 4, and then 3 pi over 2. So 9 pi over 4, and 3 pi. Then after that, we have to do our horizontal translation, and since it is subtracting, what are we actually going to do in the table? Add. We do the opposite, so you're going to add pi over 4. So 0 plus pi over 4 is pi over 4. 3 pi over 4 plus pi over 4 is 4 pi over 4 pi. 3 pi over 2 plus pi over 4. How do you add? Right, we need to have like terms when we add always. So the like terms would be our common denominator. I'm going to make that into 6 pi over 4 plus pi over 4. So 7 pi over 4. And then 9 pi over 4 plus pi over 4 ends up being 10 pi over 4, which reduces 5 pi over 2. Okay, sorry, I was thinking for a second. Okay, and then the last one, 3 pi over 4 is the same thing as 12, I'm sorry, 3 pi is the same thing as 12 pi over 4 plus pi over 4 is 13 pi over 4. I stopped for a second and thought because there is a pattern, if you notice, when they all have a common denominator, there is a pattern you could follow. What's happening each time? Pi over 4, 4 pi, 7 pi, 10 pi, 13 pi. What's happening each time? Yeah, by 3 pi adding on each time. So there is a pattern that you could possibly see if they all have a common denominator. All right, now we're going to graph that. So this is going to be a little bit challenging for me. I can't have the table and the graph up at the same time, but you guys all have the table written down, right? Okay, and then I have it on my notes over here, so I'll use this while I do it. So we have 0 and then pi over 4, but pi over 4 is not on the graph, but it's half of pi over 2, so 0 and pi over 4, 0 is right there. Oh, I forgot to put in my y's. Oopsie. My y values, it's sign, right? So 0, 1, 0. Oh, good. Thank you. Thank you for playing. Okay, so now my next one is going to be pi 1. And then after that, I've got 7 pi over 4, 0. But, like, there's no 7 pi over 4 here, so this is how I do it. They're all evenly spaced. So I just look and see how far apart these dots are. 1.5 blocks. So the next one's going to be at 1.5 blocks. So that's where 7 pi over 4 is. And that makes sense because 8 pi over 4 would be 2 pi. So 7 pi over 4 is just that half a block before it. And then from there, we're going to add on another 1.5 blocks and put it at -1. And that one, 5 pi over 2, is on your graph. And the next one is 1.5 blocks. It's off my graph, but I can still squeeze it in there a little bit. And then I have a complete cycle.
Doesn't start at
My midline is important so I don't mess up when I find the rest of the points on the graph. Because this graph should be above and then below, and then above and then below with your midline. So I'm going to continue that pattern using that 1.5 blocks each time to find the rest of my points.
I didn't know that. Oh. Okay.
How do I know what?
I didn't know.
So then we have to find all the information. And the period is affected if we have a horizontal stretch or shrink. Did we have a horizontal stretch or shrink? Okay. Can I see your eyeballs just for a moment? Don't worry, I won't be there. So if I have like one cycle in my hand, you see my imaginary cycle in there? You see it? Okay. So if I stretch it or I shrink it, the period is getting smaller or longer. Like my one cycle, if I push it together, do you know what I'm saying? Okay. But if I'm holding my cycle, but I do a translation to the side, if I do a horizontal translation, is my period changing? How about if I go this way? My period doesn't change. It's just only when you do a stretch or a shrink, the period changes. So we need to figure out the period is only affected by a stretch or shrink. What's the period of the parent function? 2 pi. And what was our stretch or shrink? What did we multiply all our x's by for this one? 3 over 2. So if I just multiply those, then I get my period. 3 pi. It's the horizontal length of one cycle, but since we had a shift in there, it's a little harder to see from the graph. Our amplitude is just a vertical stretch or shrink, which was what?
1.
1. We didn't have one, so it's just 1. Also, it is the length above and below the midline, if you have it right in the graph. The sinusoidal axis is the midline, so that's at y equals 0. Right? That's where it is. Phase shift is directional, like did we move to the left or right? Where did we move? To the right, how much? Pi over 4. So that's the phase shift. Domains always, for now, negative infinity, positive infinity. And then the range is our lowest point to our highest point, which was negative 1 to 1. Right, next. So the first thing you want to check out is, excuse me, is your B value in the correct place? Okay, so then we don't have to factor it out. It's already factored out of that parentheses. So we can just fill out our table. The 3 in front is a vertical stretch, so we multiply our y's by 3. I didn't put my y's in. I should probably do that. The sign begins at 0. And we do our stretch, multiply by 3. Then we have a horizontal stretch by a factor of 2. So multiply all my x's by 2. The plus pi over 2 on the inside is horizontal. It's opposite. So we subtract pi over 2. So I'll have negative pi over 2. And then if I take pi and I subtract pi over 2, then I have pi over 2. If I'm at 2 pi and I subtract pi over 2, I'm at 3 pi over 2. There is a pattern. It's like negative 1 pi over 2, 1 pi over 2, 3 pi over 2. What's the next one? 5 pi over 2. Or you can just do common denominators and find it. 7 pi over 2. And then we subtract 2 from our y values. And we graph the outermost points. So I can't start graphing until you guys copy that down. So go ahead and get that copy down and start graphing on your own. And I'll catch up to you. This one's off my graph a little bit, but I don't care. I can fit it on there. And then I'll continue the pattern. Make sure I know where my midline is, so I can accurately continue that pattern. I was coming over to tell you that. Was there a horizontal stretch or shrink? There was, so that means the period's different. So where the period's normally 2 pi for these, we have a horizontal stretch or shrink. We had a stretch by 2. So now the period is 4 pi. Did we have an amplitude? Did we stretch our y by what number? 3. Amplitude is never negative. Sinusoidal axis is that midline. Y equals -2, and that's because we had to translate down 2. Phase shift is left pi over 2. Domain is negative infinity to positive infinity. Range is negative 5 to positive 1. Then we try our last one. Some of you were like, I can't wait to get started. I'm going. I'm doing it. Is the b in the correct place? No. So we can factor out b. So we factor out b from that parenthesis and we get x plus what?
2x plus
Pi. If you're not sure if you factored it out correctly, just multiply it back in to see if it's the same. So now looking at this, we've got a reflection and a vertical stretch. So we multiply by negative 2. I didn't put my y's in yet. This is cosine, starts at 1. There we go.
You can combine them?
Yes.
Oh.
Yep, anything that you multiply, I just put in that one category. They are two different transformations, but we're still multiplying them. I like to do all of one side at a time. It doesn't really matter. Oh, there's nothing to do on that side. Never mind. And then over here, we're going to be multiplying by what number? Half. So we'll multiply by our fraction, 1 over 2, get pi over 4, pi over 2, 3 pi over 4, and then pi. And then we will be doing what in the C category? Subtract pi, because we do the opposite. So if you subtract pi, it's the same thing as subtracting 4 pi over 4. It's the same thing as subtracting 2 pi over 2. You're finding common denominators to do it, make it easier on yourself.
Which two did you use to get the one back? Is that the two after the cosine?
Yeah, that's the one up there. I did put a lot of 2's in that one, didn't I?
Yeah.
Gotcha. Can I go do my graph, or is anybody still copying? Yes, you're copying, or yes, I can go? Okay. You can tell what yes meant. What? Do you need it? So negative pi, negative 2. So for this one, I might not know where negative 3 pi over 4 is, but I do know where negative pi and negative pi over 2 is. So that means that negative 3 pi over 4 has to be exactly in between those, because it's in between those on the table. So I can just figure it out by plotting some of the points. I can find the other points because of what they're supposed to be in between. They are all evenly spaced. So once I have my one period, my one cycle, I look at that and I'm like, yep, that looks like cosine and it's reflected. Yeah, it kind of looks right. Then I will continue my points and get the rest of that graph there. Find my midline. And once you get going on this, it's so fun. You just got to keep going all the way off the graph, right? Follow that pattern. Don't make them look like zigzags. Did I do something wrong on that side? Yes. Can you look at it and see I made a mistake? I want you to do that with yours too. You should be able to look at yours and go, I think I made a mistake somewhere. I totally did that on purpose, just so you could like practice finding mistakes.
Oh, of course.
Does that look better?
Sure.
All right, and finally, we got to fill out our information. Was there a horizontal stretch or shrink? Yeah, there was. So we're going to take our 2 pi and we multiply by half. So the period is 1 pi. Horizontally, it's 1 pi. Here's the period. 1 pi. Amplitude is 2. Sinusoidal axis, y equals 0. Phase shift was left pi. Domain, and then range goes from -2 to positive. If you want me to go back to any of these, any of that work, I have it. But I just wanted to put this up before I stop the video. Remember, the worksheet is your assignment. Remember, Tuesday we're bringing in markers for that project that's starting.